As difficult as it sounds to synchronize with the current time on clocks, things get even worse if you need to know the local time, meaning the time that has to do with the sun and the stars at your location rather than the convention of whatever time zone you're in. One type of time is solar time, which is based on the mean sun position. Another is the local time, which is the time in your time zone. And so there's a difference between where the sun on average crosses at noon where you are, which depends on your longitude, and the place you are in your time zone. Time zones are referenced to GMT, Greenwich Mean Time, which is time zone 0. And so if you, depending where you are, you're either 1 time zone away or 2 time zones away, or as we saw before, maybe 5.5 away. But the reference for time in general is GMT plus or minus your time zone. The official time is Universal Coordinated Time, UTC. That's a French abbreviation. That's why the letters are in a different order. And they differ from each other based on whether or not there's a leap second, which we'll get to. For practical purposes, for most purposes, people would say GMT as the 0 time zone and then say I'm in GMT plus or minus some number to indicate which time zone they're in. But back to solar time, sunrise and sunset depends where you are. The sun rises earlier the further east you go, and within a time zone, you're going to find out that the sun rises and sets at different times depending where you are in the time zone. There's some particularly wide time zones. For example, Boston to Detroit has a very significant delay between when the sun rises and sun sets in local time. But even bigger is China, which is all in one time zone. And since China's all in one time zone, what you find out is that the sun rises a whole lot earlier in the eastern part of China than the western part of China, and there's a really significant number of hours of difference there. If you have an application that needs to compute when the sun rises and sets, for example, you want to do automatic shades that sort of keep the sun behind the shade while letting light into the room, or you're building a navigation system that depends on the sun and the stars, for example, you have to know that sunrise and sunset depends on where you are, both latitude and longitude, but also your altitude. And the sun angle and the length of the day change every single day through the year as you go through summer and fall. So if you actually want to know where the sun is and do some sort of computation, you have to know latitude, longitude, altitude, but you also need to know that the local time, as I mentioned, was based on the mean sun. That's not the actual sun position. It turns out the sun moves backward and forward at local noon time. Sometimes the sun will cross the noon line before noon, sometimes after noon, and it can be several minutes difference. There's a thing called the equation of time you can look up. Usually you look at something like a nautical almanac, and it will tell you for every day of every year exactly where the sun is compared to the mean sun. And so if you need to know where the sun is, you figure out what your local time is based on your position, and then you figure out what the equation of time is, which is the difference between the mean sun and the actual sun, and that tells you where the sun's going to be at a particular time on a particular day. This sounds complicated? That's right, it is. It's a very difficult calculation, but if you need to know where the sun is, you have to take all this stuff into account.